Every year, millions of tons of sugarcane are transformed into the white sugar commonly found in homes and industries worldwide. This transformation is a marvel of modern agriculture and industrial processing, showcasing the ingenuity and hard work of countless individuals. This massive production process from field to factory involves multiple intricate stages. Each stage is meticulously planned and executed to ensure efficiency and quality. Each stage plays a crucial role in determining the final product's quality and characteristics. From the initial harvesting to the final packaging, attention to detail is paramount. Sugarcane, a tall tropical grass, thrives in warm climates. Its growth is a testament to the power of nature and the importance of suitable environmental conditions. It efficiently converts sunlight into sucrose, the basis of table sugar. This natural process is both fascinating and essential for the production of sugar. Brazil, India, and China lead the world in sugarcane production. These countries have vast areas dedicated to sugarcane cultivation, supporting their economies and providing employment to millions. These countries contribute significantly to the global sugar supply. Their efforts ensure that sugar is available in abundance for various uses around the world. The journey from sugarcane plant to white sugar crystals is a complex one. It involves numerous steps, each critical to achieving the final product that we all know and love. It involves a series of industrial processes that have evolved over centuries. These advancements have made sugar production more efficient and sustainable. Understanding these processes reveals the journey of this ubiquitous sweetener and its impacts on the environment and society. The story of sugar is one of innovation, tradition, and global significance. The journey of sugar begins with the harvest. This is the first and one of the most crucial steps in the production of sugar. The process starts in the vast fields where sugarcane is grown. Sugarcane stalks are typically harvested after a year of growth. During this period, the plants reach their full height and sugar content. Harvesting can be done manually or mechanically. Each method has its own advantages and challenges. Manual harvesting involves cutting the stalks close to the ground using machetes. This traditional method requires skill and precision. This labor-intensive method is still common in some regions, especially where labor costs are lower or machinery is not accessible. Mechanical harvesting utilizes large machines to cut and gather the cane. These machines can cover large areas quickly and efficiently. After harvesting, the sugarcane is transported to mills for processing. This step is crucial to ensure the cane is processed while it is still fresh. The efficient transportation of sugarcane is crucial to minimize sugar loss. Delays can lead to a significant reduction in the quality of the final product. Freshly cut cane begins to lose sucrose content rapidly. Therefore, timing and speed are of the essence. Therefore, mills are often located near sugarcane fields. This proximity helps in reducing transportation time and preserving the quality of the cane. The timing of the harvest is critical. Farmers must carefully monitor the growth and maturity of the cane. Sugar content in the cane peaks at maturity. Harvesting at this time ensures the highest yield of sugar. Harvesting too early or too late affects the yield and quality of the sugar produced. Timing is everything in this delicate process. Factors such as weather, soil conditions, and cane variety also play a role in determining the optimal harvest time. Each of these elements must be considered to ensure a successful harvest. At the mill, the sugarcane is first washed and chopped. This initial step is crucial as it removes dirt and other impurities from the surface of the cane, ensuring that the subsequent processes are more efficient and the final product is of higher quality. This prepares it for the crucial extraction process. The chopped pieces are then conveyed to the milling section where the real magic begins. Heavy rollers then crush the prepared sugarcane. These rollers apply immense pressure to extract as much juice as possible from the fibrous stalks. This process extracts the sugary juice contained within the stalks. The extracted juice is a mixture of water, sugar, and other natural components. The remaining fibrous material, known as bagasse, is often burned as fuel for the mill. This not only helps in waste management but also provides a renewable source of energy. This reduces reliance on external energy sources, making the entire process more sustainable and cost-effective. The extracted juice, a cloudy greenish liquid, undergoes further processing. This raw juice is rich in sugar but also contains various impurities. It is strained to remove impurities like plant fibers and soil. This straining process is essential to ensure the purity of the juice before it moves on to the next stages. This raw juice contains impurities that affect the taste and appearance of the final sugar product. Removing these impurities is a critical step in producing high-quality sugar. Therefore, it undergoes several purification steps before crystallization. These steps ensure that the juice is clean and ready for the final stages of sugar production. The efficiency of the milling process directly impacts the amount of sugar extracted. Efficient milling means more juice and, consequently, more sugar. Modern mills utilize advanced technologies to maximize juice extraction. These technologies include automated systems and precision equipment that enhance the overall efficiency. These technologies help optimize sugar production and minimize waste. By reducing waste, mills can operate more sustainably and produce sugar more economically. The raw sugar undergoes a series of purification steps to remove impurities. The juice is treated with lime and heated. This process helps separate impurities from the sugar solution. These impurities rise to the surface as a scum, which is then removed. The clarified juice is then boiled in large vacuum pans. This process evaporates the water, concentrating the sugar solution. As the syrup concentrates, sugar crystals begin to form. These crystals grow in size as more water evaporates. The resulting mixture of sugar crystals and syrup, known as massicrete, is then spun in centrifuges. This process separates the sugar crystals from the remaining syrup, known as molasses. The separated sugar crystals are then dried and cooled. Section 5. Packaging and distribution, from factory to table. The dried sugar crystals, now recognizable as white sugar, are ready for packaging. Automated machines package the sugar into various sizes and types of bags or containers. These packages are designed to protect the sugar from moisture and contamination during transport and storage. The packaged sugar is then transported to distribution centers. From there, it is shipped to retailers and wholesalers worldwide. The sugar supply chain is a complex network that ensures a consistent supply of this essential ingredient to consumers. Different grades of sugar are produced to meet specific industrial needs. These grades vary in crystal size, color, and purity. Fine granulated sugar is commonly used in households, while coarser varieties are preferred in baking and confectionery. Section 6. The environmental toll of sugar production. While sugar production provides a vital food ingredient, it also raises environmental concerns. The industry's reliance on large-scale agriculture can contribute to deforestation and habitat loss. This is particularly concerning in biodiversity hotspots where sugarcane is grown. The processing of sugarcane requires significant amounts of water and energy. Water usage for irrigation and processing can deplete local water resources. This is a growing concern in regions facing water scarcity. Furthermore, the byproducts of sugar production, like bagasse and molasses, require proper management. Improper disposal of these byproducts can pollute water sources and contribute to greenhouse gas emissions. The industry is continuously exploring sustainable practices to minimize its environmental footprint. Section 7. Social impacts, the bitter side of sweetness. Beyond environmental concerns, sugar production raises social issues. The industry has historically relied on low-wage labor. This raises concerns about fair wages and working conditions for those involved in sugarcane harvesting and processing. Furthermore, the global demand for sugar has led to land conversion for sugarcane cultivation. This can displace local communities and disrupt traditional farming practices. The sugar industry must address these social implications to ensure ethical and sustainable production practices. Efforts are underway to improve labor conditions and promote fair trade practices within the sugar industry. Consumers are increasingly aware of the social impacts of their food choices and demand greater transparency and responsibility from producers. Section 8. The future of sugar challenges and opportunities. The sugar industry faces challenges and opportunities in the coming years. Fluctuating sugar prices, changing consumer preferences, and environmental concerns require the industry to adapt. Innovation in sugarcane breeding can lead to varieties with higher yields, disease resistance, and improved environmental performance. These advancements can contribute to a more sustainable and efficient sugar production system. Moreover, the industry is exploring new technologies to diversify its product portfolio. This includes developing bio-based products from sugarcane byproducts, such as biofuels and bioplastics. These innovations can reduce reliance on fossil fuels and promote a circular economy. Section 9. Seeking sweetness elsewhere. Sugar alternatives. Concerns about the health effects of excessive sugar consumption have led to a growing market for sugar alternatives. These alternatives, ranging from natural sweeteners like stevia and agave to artificial sweeteners, offer consumers options to reduce their sugar intake. While these alternatives provide sweetness, they may not have the same functional properties as sugar in food processing. Moreover, some artificial sweeteners raise health concerns, prompting ongoing research and debate. The choice between sugar and its alternatives is a complex one. Consumers must weigh factors such as taste, health impacts, environmental considerations, and ethical production practices. Ultimately, a balanced approach to sweetness, focusing on moderation and informed choices, is key.